Hi and welcome to Excel QM Quantitative Analysis. In this video I will be describing how to formulate a transportation problem or using linear programming in Excel QM. Alright, first thing that you need to do is click on the Excel QM tab, alphabetical, and this is a transportation problem. Alright, in your transportation you will have a certain amount of origins and a certain amount of destinations that you are shipping to. So in this particular example I'm going to use a balanced transportation problem with 3 origins or sources and 3 destinations. Alright, the main objective in our problem is to minimize the total shipping costs. Alright, go ahead and click OK, and that will bring up a new tab. I'm going to switch back over to the one that I had because I wanted to explain some about the objective function and the constraints. So in a balanced transportation problem, the number of sources that you have will equal the number of supply constraints, and the number of destinations presented will equal the number of demand constraints. Alright, in this problem you can see 3 origins and 3 destinations. 3 sets of demand and 3 sets of supplies. Alright. So basically what I've done, or what you may want to do, is kind of make a template so you can just, first of all, know what your information represents, and secondly, that way you can either, if you're given a table, you know how to write the objective function along with the constraints. Or if you're giving the objective function and constraints, you know how to formulate the table. Alright, so click on Excel, QM, alphabetical, and we're working on a transportation problem. So these numbers that are entered here is what can be seen in your objective function. Your supply, and I've kind of color coded this so you can see if you're building a template of how to do it. Supply and demand will be your right hand side of your constraints. So we have 100, 300, and 300 for our supply, and 300, 200, 200 for our demand. So those two numbers should match up. So let's look at the first worksheet again. We have 3 origins and 3 destinations. So how many sources do we have? 3. Destinations, 3. That's also going to be the number of supply constraints that you have and demand constraints that you have. Okay, the number of nodes equals the sum of your sources plus destinations. Your number of arcs, how many different trips you could take, equals the product of the number of sources and the number of destinations. Alright, so now that we have our data entered, we can click over to the Data tab, go to Solver, and simply hit Solve. Alright, and what that will do is fill in this second table worth of information. let's copy what we have entered here into here as well, so it's a little bit easier to see. Alright, you can tell whenever you click solve, it go ahead and automatically formulates how many occupied cells there are. In this case, there's 1, 2, 3, 4, 5. But if we weren't given a table and asked how many occupied cells there were, the way that you do that, it equals the number of nodes minus 1. Now in an assignment problem, that's different, but we'll discuss that next video. The number of non-occupied cells equals the number of arcs minus the number of occupied cells. All right, we also have 3 demand constraints. All right, and that is basically a good way to set up a template for a transportation problem using linear programming. If your transportation problem has a second step to it, all you need to do is just add another worksheet, and you can enter more data by simply setting up another problem. All right, maybe using the information that you already have. All right, and then you could analyze different decisions that you would like to make. XLQM, transportation problem for linear programming.